Hello all, how are you? I hope everyone is doing well. So let me start with the problem of the day for today. Okay, let me go with the problem description and we'll discuss with an example how it is. Okay, so we'll be given an integer n and we need to return the decimal value of the binary string formed by the concatenating the binary representation of 1 to n in order. So you need to do modulo 10 power 9 plus 7. So this is what they are stating. So let me explain the uh, problem with the my pad. Okay. So yeah, they will be given an as an input for us. Okay. And we need to uh, return the decimal value of the binary the concatenation of binary representations of 1 to n. Okay, so for from 1 to n, we need to convert the 1 to numbers to binary and we need to combine or concatenate them to form a number and we need to return that number. And they have also mentioned that because when you try to do this, we will end up getting a huge number where you cannot store in any data type. You cannot store in int, you cannot store in log, you cannot store in a double also. Okay. So for that purpose, they have mentioned that take mod is equal to 10 power 9 plus 7. Okay. This is what the input constraints they have given and this is what they have been expecting us to return. Okay. So if we understand the problem well and if we want to solve this problem, then we might go brute force. So that is, hmm, let me explain. Okay. So the brute force way, let me change my frame. So brute force way, okay. Let's suppose I'm taking example n is equal to 5. Okay. So the brute force way is that start from 1 and go till 5 and so every time generate its binary and concatenate. This is what the brute force way we can do. See, I'll start from 1 and I'll just represent it in binary form which is 1. I'll take 2, it is 1 0 and I'll take 3, it is 1 1. I'll take 4, it is 1 0 0. I'll take 5, which is 1 0 1. Okay. So the brute force way is that. So I'll go and generate all this and what I'll do, I'll just store all of these guys in some data structure and what I'll do, I'll just start from 1. So I'll start uh, constructing the binary representation of my final number. So that will be 1 1 0 1 1 0 1 1 1 double 0 101. So I'll construct this, and after this, I'll just convert this into a number, and I'll just modulo it, and I'll just return. So this is the extreme brute force solution that we can think of. Uh, okay. So, but here there is a problem where I'll ask one question, that is, what is the max int can store? What is the max number of bits that int can store? So it is 32, right? And for long also it will be 64 only. Okay. So when you try to do this approach, then you might exceed this 64 also. Okay. You might get the length of bits which is greater than 64 also. Okay. So in that case, you can't store that number in any uh, data type. Okay. So for that purpose, we cannot use this brute force solution, as n can be 10 power 5. Okay. So 10 power 5 means it can have in binary representation, it can have 20, nearly 20 bits, right? So when you concatenate 20 plus 19 plus 18 like this, you will end up getting more than 8, 120, nearly 200 also. Okay, so you can't store all of these guys in any data type, right? So we need to think, and we need to apply some pattern. We need to recognize some pattern in this way where everything is okay, but this generating of this whole guy and converting that into number is the problem for us, right? In the brute force way. So when you come up with the brute force solution, then identify the problem where we cannot like we cannot we can optimize where it is causing problem, right? So here it is causing problem, and what I'll do, I'll just optimize this to get easily, like without generating code. I use some logic, some technique, or some pattern. Okay, so, so from the problem statement, I can think of something like, so whenever you are concatenating adjacent guys, right? Okay, so what do you think of? Let me take one, two example. One and two, 1, 0. Okay. So till two, I'm saying. So it is the answer is three, right? How when I write 1, 1, 0, then uh it will become 4 plus 2. It is 6, right? So it will become 6, right? So what I'll do, so before concatenating with this guy, I will just shift this one, the number of bits it has, right? So that will become 1, 0, 0, right? And I'll just add this guy 1, 0. Then it will become 1, 1, 0, right? So this is the property that I can think of. So here I need to use bit manipulation. So that is a pattern, that is the logic that will optimize our problem in this case. So we need to use bitwise or bit manipulation logics. Okay, so this is the one. Okay, so whenever I I want to concatenate, I just shift to my left. How many times? I just shift the number of the length of the next guy whose binary representation is. So then the length of the binary representation of the next guy, that many times I just left shift, and what I'll do, so I'll just add that guy. So left shift plus number, add num. Okay. So this is what it will look like, and it is a optimization that we can do. So every time I'll get a number, right? Every time I'll do my mod. So that will never cross my limit, because if I take long, it can be 64 bits, right? So you can at max you can do at max left to shift 32 times, right? So if I if my current number has 32 bits, and if I do 32 times left shift, then it will fit into 64, that is long. So I can store that, right? So that is what it makes sense, and that is what we need to do in this problem. So that is the logic behind this, and you can easily do other things easily, because this is what the main problem. Other things I have already discussed. So let me try to code this up and see if it is working or not. So this is the let me just drag, and they'll be given n. So I'll take long answer equal to 1, and what I'll do, I'll write a function to get the length of, like, I will write in comments. So function to get the length of binary representation of number. So I'll just write the function what it is in 10. Okay, so I'll just take int answer equal to 0 while n is less than 0 and answer plus plus. I'll just right shift to this guy. So at the end, I just return answer. Okay, perfect. Now, so I took your answer, and I'll take current length. So that is L equal to 1. So I'll start from 2. So for 1, I can say it is 1, right? So for int I equal to 2 and I is less than or equal to n, I plus plus, and I just uh, this is not required, I think so. So I just declare a count here, and count equal to f of, I just call the function. So while my count is minus greater than 0, then I just what I'll do now. I just right shift to my answer or left shift to my answer. Okay, and after that, answer plus equal to I, and answer equal to answer mod. Okay, so mod I'll do. I'll take return the answer. Perfect. Here I'll just declare mod equal to int 189 plus 7, right? Okay. Mm, perfect. This will be the case, I think so. So let me try to run this up, see if it is working fine or not. Mm, there is a mistake written there. Okay, I need to convert it this guy to uh, int, right? Okay. I think it is working fine, and let me try to submit, see if it is working for all test cases or not. So it is given accepted, so it is correct. And one more thing, the time complexity and space complexity can be. So we are not using anything so to store. That is space complexity will be big of one, right? And whatever we are doing, we are iterating over the n times, so this will become n, and we are asking count every time, so this will become log n. So orally, the space complexity will be time complexity will be big of n log n. That will be it. And if you want to optimize this log n complexity, so we can use of one more bit manipulation operation. So that is, instead of going till the count, so I'll just remove this guy. And what I'll do, so I just use here a global length equal to one. And whenever there is a property that you might notice it. So whenever I and I minus 1, so they both are they will give 0 means there is a increment of length. Okay, so I just take here a count equal to L. Okay, so this is also works, I think so. Let me take and try to run this. So it is also working. Let me try to run, submit, and see, you can see that it is correct. So this will take big of n time complexity because we are not doing every time, right? So this is what it will. And if you understood, please do like, share, subscribe. Okay. So keep supporting. Thank you.